This is the 2025 Higher Level Maths Leaving Cert Paper 2, question 5. The diagram shows two triangles ACD and BCE. So we've got this triangle and this triangle here. C is the midpoint of AB. That means that's equal to that there. AD is parallel to EB, so that's parallel to that one there. And the point C lies on DE. Prove that the triangle ACD and BCE are congruent. Give a reason for each statement that you make in your proof. Okay, so what we'll do is we'll call this angle 1 and this angle here 2. We'll call this angle here 3 and we'll call this angle here 4. And we'll call this angle 5 and this angle 6. So what I'm going to say first here is that the size of the angle 5 is equal to the size of the angle 6, and the reason for that is that they're vertically opposite. You can say that the length AC is equal to the length CB. We're given that because C is a midpoint of the line segment AB. You can also then say that the size of angle 1 is equal to the size of angle 2. They are alternate angles. So what we've done is we've shown these two angles are equal. This side here is equal to this side here, and angle 1 is equal to angle 2. So we have an angle, a side, and an angle. And remember, the side has to be between the two angles, which it is. This side is between 6 and 2. This side here is between 5 and 1. So we can now say then that, therefore, triangles ACD and BCE are congruent by angle, side, angle. And that's it. That's all you have to do for this part of the question. Okay, so let's look at the next question. So the parallelogram on the right, PQ or S. So we got PQ or S here. The point X lies on the line PQ. So that's the line PQ here, and X lies on that. P dash Q dash R dash S dash, so that's this parallelogram up here, is an enlargement of PQRS using the point X as the center of enlargement. So they give us some measurements here. So the distance from X to Q is 8. So this distance here is 8 centimeters. That's the distance from here to here. The distance from Q to Q dash is 4. So the distance from here is 4 centimeters from Q to Q dash. Show that the scale factor of the enlargement K is 1.5. So what you would say there is K is going to be equal to the distance from X to Q dash divided by the distance from X to Q. So that's equal to 8 plus 4, which is 12 over 8. So the scale factor is just 1.5. That's it. Okay, so this is part 2, P, Q, or S, and P dash, Q dash, R dash, S dash. That's this parallelogram up here. They're shown in the diagram. Y is a point where the lines SR and P dash, S dash intersect. So this is a line here, this is a point here, and it is on this line segment here, SR. The region P dash Q or Y is shaded. That's this parallelogram here. XP is 3, so this distance is 3. The area PQRS is 20, so 20 square centimeters. So this parallelogram here has an area of 20 square centimeters. We have to use this to find the area of the shaded region P dash Q or Y, so this shaded region here. So I've drawn this, or I've copied this diagram down here again so that I can put in some measurements that were given. We know, for example, that the distance from here to here, from X to Q, is 8 centimeters. We were given that earlier. We are told now that this distance here is 3 centimeters. That's from P to X, or from X to P. So if we subtract those, that'll give us 5 centimeters from Q to P. So we have the base of our parallelogram PQRS, and we have the area of our parallelogram PQRS. If you remember, the area of a parallelogram is equal to the base times the height. The area of our parallelogram is 20 square centimeters. The base we now know is 5 centimeters, and we don't know the height, so we can work that out. So the height then is just 4 centimeters. So I can now mark in the height of the parallelogram that's 20 square centimeters in area, but that height is also the height of the shaded parallelogram, which is what we're looking for. So our height here is 4 centimeters from there to there. Okay, so the next thing we've got to do is try to find the base of our shaded parallelogram. So what I'm going to do is just work out the base of this big parallelogram first. So we know the base of the small parallelogram is 5 centimeters. So all we've got to do is multiply that by 1.5 scale factor. So take 5, multiply it by 1.5, and that'll give you 7.5 centimeters. So I've now got the base of the large parallelogram. So this is 7.5 centimeters from here to here. However, we were told earlier that from Q to Q dash is 4 centimeters. It's 4 centimeters from here to here. So all we've got to do is subtract those, and that'll give us the base of our shaded parallelogram. So in other words, we take 7.5, subtract 4, that'll give us 3.5 centimeters, and that's the distance from P dash to Q. So now we have the base of we have the base 3.5 centimeters here of our shaded parallelogram. We also have the height, so we can work out the area. So the area then of P dash Q or Y is just equal to 3.5 multiplied by 4, and 3.5 multiplied by 4 is 14, and that's centimeters squared.